Good morning to one and all. I am Parthiban, working as assistant professor in the Department of Electronics and Communication Engineering. Now I am going to talk about the subject called satellite communication, which is coming under the regulation R 2021. The subject code is CEC 352. First of all, I am going to deal about the syllabus of satellite communication. Satellite communication in the unit 1, it deals about the satellite orbits. It deals about the various laws, that is Kepler's laws, Newton's laws, orbital parameters, orbital perturbations, and a limit of visibility as well as about the look angle determination. In the unit 2, it deals about the space segment and its properties. How we are going to position the satellite, how we are going to maintain the satellite position, how we are going to control the thermal and other things. In the unit 3, we are going to see about the satellite link design. So it basically deals with the link analysis, that is uplink as well as the downlink equations, as well as about the losses that are various losses that are occurring. All the things we are going to take into account before designing the satellite. In the unit 4, we are going to deal about the satellite access system and coding techniques. Actually, we are going to use various modulation and multiplexing techniques for both voice, data, video, as well as the digital transmission system. So we are going to study about the FDMA, TDMA, TDMA, CDMA, DAMA, and other things. We are going to study about the various compression techniques as well as the encryption techniques as well as about the coding. In the unit 5, we are going to deal about the satellite applications, the various applications of satellites, that is the GSM, GPS, as well as DBS, DTH, like that. So in the unit 1, I'm going to talk about the introduction to satellite communication, the various laws of communication, as well as the frequency allocation methods and techniques, as well as the regulatory aspects and its governing bodies, and what are the various applications of satellite communication. What is satellite? A satellite is a word that is originated from the Latin word satellite, meaning is an attendant who is constantly hovering around and attending to a master, or we can say it's a big man. Satellite is the master which is governing all the things. Basically, the satellite communication involves three important things. One is ground station, the other one is satellite, the third one is destination or ground station, we can say. In the satellite communication, there are four parts, important parts. The earth stations contains an antenna system which are embedded on the earth station. Then the signal that is going to be transmitted from earth to satellite is called uplink. That is, we are connecting the signal from earth to the satellite. That process is called uplink process. The same opposite process, that is transmitting the signal from the satellite to earth, is called a downlink process. So both the things are governing the satellite communication. We are using an important device called transponder. A transponder is a device which is nothing but we can say it's a modulator or a multiplier or a mixer or an interface. Transponder is connected in both ways. That is, in the uplink also we are using transponder. In the downlink also we are using the transponder. Transponder plays a vital role of frequency conversion or frequency translation, or we can say modulator, or we can say it's a multiplexer like that. So transponder only decides the number of channels that can be transmitted, as well as the transponder only decides the number of channels that can be received in satellite communication. The introduction to satellite communication. Satellites are generally specifically made for telecommunication purpose only. They are used for nowadays mobile applications as well as for TV as well as for radio broadcasting also nowadays. Satellite communication is responsible for assigning a particular region in the earth to monitor and govern the activities that are going on. Satellites are preferred because of its footprint, because of its complexity of traffic control protocol schemes because of its availability of the very good earth stations. Satellites works most effectively when the transmissions are focused in the desired area. That particular area can be monitored and governed independently. There are various applications nowadays on satellite communication, starting from the weather forecasting system, as well as the radio and TV broadcasting system, as well as it is particularly used for military as well as for surveillance purposes. It can be used very widely for navigational purpose also. It can be used for global telephone communication also. It can be used for connecting a remote area with the server. Then coming on the next important one, the global mobile communication now depends badly on satellite communication only. There are three basic laws that governs the satellite communication. First, it is called Kepler's three laws. The Kepler's first law states that each planet moves in an elliptical orbit with its star at one focus. Rather than we can say the first law, the movement of a satellite is an elliptical orbit. That's what the first law states. In the second law, the equal areas will sweep out in equal time. That is called the second law, that is the law of equal areas. In the third law, which is nothing but the A cube is equal to mu by n square. That is, the square of the planet's orbit time is proportional to the average distance from the star cube. That is the third law of Kepler. In the next important law that also governs the satellite communication is Newton's law. Newton's first law of motion, that is nothing but the law of inertia, we can say that what it states that every body continues in the state of a uniform motion unless or otherwise it is disturbed by a force that is imposed upon it. So the state of rest is always in continuous state unless or otherwise it is disturbed. This is called the law of inertia. The second one is Newton's second law, that is called law of momentum, but it's nothing but F is equal to ma, which is the force applied is nothing but the multiplication of mass into acceleration, or we can say velocity. So the change in momentum is proportional to the direction of the force applied. That is what the law of momentum states. The important law, that is third law of motion, that is nothing but is called the Racket law. For every action, there is an equal and opposite reaction. This is what the basic principle of rocket launching lies. Then the three important laws, these are the vital roles in the satellite communication. The first law, the second law, and third law. These are the basis for satellite communication. Then we are going to talk about the frequency allocation and regulatory aspects of satellite communication. The frequency band for satellite services are shared with the terrestrial services. The satellite strength is considered to avoid interference by other users. There are large antennas and sensitive receivers that are needed at the end station. Frequency sharing is a very important area and important role to play in satellite communication. The frequency sharing can be achieved by means of TDMA, CDMA, FDMA, and SDMA techniques. Many satellites have the system of shared limited frequency band. Then we are also using the concept of frequency reuse. Generally, the frequency allocations and maintenance are governed by the international agencies. The various regulatory aspects or the governing bodies are in the domestic level, there is called the FCC in the United States, that is Federal Communication Commission. In the next one, there is a NITA, that is called National Telecommunication and Information Administration, that is also from US. In the Pakistan, it is having a telecommunication authority that is called PTA, Pakistan Telecommunication Authority. In India, we are having a system called TRAI. The TRAI governs and controls the entire telecom networks in India. The expansion for TRAI is nothing but a Telecom Regulatory Authority of India, which is the governing body of Indian telecommunication services. In the international level, we are having a ITU, which only governs the overall international level communication. That is, International Telecommunication Union (ITU) is formed in 1932 from the International Telegraphic Union, consists of over 150 member nations, which is the governing body of the whole world. ITU decides all the things. There are some regulatory aspects also that is there. The first one is called WARC, which is nothing but the World Administrative Radio Conference. Then the next one is that is CCIR, which governs the TV transmission as well as radio transmission, which is consists of actually 13 groups. It is called International Radio Consultative Committee. That is the expansion for CCIR. Our world, that is the global, is divided into 3 regions of communication for satellite communication. The first region covers the Europe, Africa, Soviet Union, and Mongolia. The second region, that is region 2, covers North and South America as well as Greenland. In the region 3, we are having Asia, Australia, and Southwest Pacific. These are the 3 regions that we are going to cover in the international level by means of satellite communication. The satellite communication offers the different types of services for our society. The first one is called fixed satellite services. A radio communication that service between the earth stations at given positions when one or more satellites are used is called fixed satellite service. Particularly, it is nothing but the space research application. We are using the fixed satellite services. And the next one, we are going to see about the broadcast satellite services. Under this only, we are having the DTH. We can see that is direct to home or direct broadcast satellite system. By means of this, the TV programs are transmitted and received globally. The next one is mobile satellite services. That is called the MSS. It is a two-way voice and data communication for global users who, wherever they go, on remote locations also, they can be covered quite easily. The satellite as a mobile communication provides a very useful background for human society. The next important application of satellite lies in the navigational satellite services. The navigational satellites provides the weather forecasting, the long-time navigational with accurate geometric positions as well as speed and direction of the vehicle as well as aircraft. For reference, we can say for military purpose also we can use the navigational satellites. The next important application is meteorological satellite services, which is used to detect and develop the weather forecasting, cloud patterns, meteorological analysis, we can say, the effect of fires, the effect of lights, the effect of pollution, the effect of dust, the effect of storms, the effect of snow, the effect of ocean winds. So these are all the various things that we can able to study by means of the satellite system. These are the prime applications of satellite design. Generally, the satellite communication configuration can be a point-to-point link communication, or it can be a multi-point or broadcast link communication. In the point-to-point communication link, there is only one transmitter and one receiver between the earth as well as satellite and earth stations. In the multi-point communication system or broadcast communication system, there are multiple transmitters, there are multiple receivers that can be connected via a satellite communication. This is the important thing that we have to observe. Generally, the satellite orbits are classified into 3 ways. One is called lower Earth orbit, the other one is called medium Earth orbit, the other one is called geostationary Earth orbit. The difference lies in the range of kilometers only. So in the LEO, we can able to have the height of up to 2000 kilometers altitude only. That is particularly used for remote sensing as well as altimeter satellites. In the MEO, there is a range that is called 5000 to 20,000 kilometers away from our Earth. The satellites that are coming under the MEO are called GPS satellites. That is called global positioning satellites. That can be used for positioning to know about the position of a satellite, to position of the human beings. In the next category, that is called geostationary Earth orbit satellites. So, which is placed in the height of altitude of 36,000 kilometers, particularly very useful for communication purpose. So, this geo only provides the global communication for satellite communication. So, by means of using geo satellites, we can able to provide a global coverage. So these are the broad classification of satellites based on the height of position it has been planted. So with this, I am winding up the lecture. Thank you one for all hearing my lecture. Thank you one and all for hearing my lecture. Thank you very much.